So in this video, I will be explaining model selection. Model selection is an approach to improve the performance of either linear regression model or logistic regression model, that is the classification. This model selection is done in two different contexts. That is, first one is the regression and second one is the classification. So before starting the discussion on the model selection, I would like to define different kinds of errors, and I am calling it as the error terminology. As you know that an error is defined as a difference between actual value minus the predicted value. It is the purpose of machine learning model is either to predict the class label or to predict the numeric value in case of the regression model or linear regression model. And this difference is called as the error, or for individual one it is called as the EI, and we usually take the square of this difference because we need to make it as the positive error difference. So this is the definition of the error, of individual error. Now when we add these individual error terms together, if there are n number of different data observations are there, then we need to add the n error terms, and that addition of those n error term is called as the residual sum of squares, or in short it is called as the RSS. And when we take the average of this RSS, we get the mean square errors. Mean square error is the ratio of RSS to the n, or it is average error. So this is the definition of the mean square error. Then third definition, third error term that is commonly used is called as the explained sum of square. In this error description, I am referring y I cap means the predicted value or the estimated value, individual estimated or the predicted value, and y is the actual value, and y bar is the average of y. So these are the notations here. This explained sum of square is the difference between the estimated, this y I cap is nothing but the estimated predicted value minus y bar is nothing but the average y. So this difference, the square of sum of the square of this difference is called as the explained sum of square. Then also there is the fourth error term that is commonly used is called as the total sum of squares, and it is defined like the individual value of output variable, y means the output variable, minus its average value. So that is the when you take the square of this term, then it is and add together, so that term becomes the total sum of squares. So all these errors terms are defined in the context of the regression problem. And we also know that we are typically use a term called R square. R square is nothing but 1 minus ratio of RSS divided by the TSS, where the RSS means the residual sum of square and TSS means the total sum of squares. So these are the different terms that we are going to use for describing the model selection. Now, let us first define the problem of model selection. What does it mean by the model selection? And I am describing the model selection problem in the context of our task of predicting end semester marks from the given four different variables are there. One is the previous semester CGPA, then the X2 is nothing but the attendance in the current semester, then x3 is the gender of the student, x4 is the mid-semester examination marks, and ESC is our output variable or the dependent variable. So these four variables are independent variables or input variables, and this is the output variable or dependent variable. So it is the in case of the linear regression, we typically develop a model which is f, whose purpose is to predict the value of y, that is the output variable, from the given n number of input variables. So when there are n number of different variables are given, there are multiple ways in which you can build a model, either with different combinations of those models. See here, uh, in the first simple case, you will use only one variable. Like you will develop a model using only single variable. Like suppose f is a function of CGPA, previous semester CGPA, or you may develop using attendance. In which case, there you are going to use only single variable, and you can estimate the your objective is to estimate the end semester marks using one single variable. So this is one way in which you can develop. In second way, you can use the more than one variable in order to improve the model performance, that is the accuracy. You may use more than one variable, like you can use the CGPA plus attendance, CGPA plus gender, CGPA plus MSc, or attendance plus gender, attendance plus MSc, or gender plus MSc. So these are four number of see these are the four number of different way in which you can develop the model using two different there are six ways in which you can develop the models using two input variables. If you have decide, if you are planning to develop a model using only one single variable, you can use, there are four number of ways in which you can develop the model. If you want to use the three variables, then again there are four approaches are there. These are the four different approaches are there. So you either you can use CGPA, attendance and gender, CGPA, attendance or a mid semester examination mark, attendance, gender or mid semester examination mark, CGPA, gender or MSc. So these are the four different ways in when you want to use the three input variables. If you want to use the all four variables, then there is only one way. And if there are p number of variables are there, p number of input features are there, then there are 2 to the power of p possibilities are there for developing the model. And you want to select 2 to the p means that here in this case there are 4 variables are there. So there are 16 models you can develop. Here these are the 4. Here 6 plus 4 10. Here 4 14. This is one 15. And this model, the last one is model in which you are not going to use any input variable, means that is called the k equal to 0, and that model is called as the null. In that case, your predicted value is always the average of the output variable. So this model is called as the null model, and hence there are 16 number of models you can develop when the p is 4. Or in general, if you have the p variables, you can the number of models that you can develop is equal to 2 to the power of p. And out of this 2 to the power of p, your the model selection objective of the model selection step is to select one model which gives the best performance. Now, when I am saying that the purpose of the objective of the model selection is to select one model out of these 2 to the power of p models, then I need to have some criteria to define which is the best model, and I need to have some method out of which I can select this one model out of this 2 to the power of p different possibilities. Now, before discussing the model selection in details, uh, we let us see why we need to do the model selection. The purpose of the model selection is to improve the model accuracy. As we know that when we use only one single model or only like in case of no variable, so the prediction there is very high prediction errors are there. When we use only one single input variables, then again there are high amount of prediction error may present, and what we want to reduce the error in model prediction, and that's why we go on adding the input variables. So this is the one way in which you can improve the model performance. So we need to identify a set of input features which will give you the best model performance. So the first objective of the model selection process is to improve the accuracy of the model. The accuracy means to improve the prediction accuracy. In the second objective of the model selection process is to improve or to reduce the model complexity or to improve the model interpretability. So to reduce the model complexity means that using smallest number of features, we want to improve the prediction accuracy. See, when we are using only one single variable, so that model is very simple model as compared to the number of variables that you are using is if it is the two, then the if the model is using the two input variable, that model is simpler as compared to the model that is using the three variables. So we want to improve the model interpretability or to reduce the model complexity. So this is the objective of model selection step. Now, while selecting the models, we need to have some criteria, which means that which tells us that which model is the good model and which model is the bad model. And so far we know that we use the term called residual sum of square to indicate which model is good and which model is bad. If our model has the residual sum of square is smaller, then that model is the good model. The residual sum of square is nothing but uh, it is the sum of actual difference between the actual value and the predicted value and its square. So that sum is called as the residual sum of square. If the smallest if the amount is the smaller, then that model is called as the best model. But this is the general when you this is the very general term. There are then this general term is specialized further to give the best performance. And now I am here defining different kinds of metrics that are used while selecting the models. And while defining in these metrics, the metric that I am going to define now, I am using these terms. N means the number of data observation, or number of n means the number of data observations, or it is nothing but the size of the data. K is the total number of input features, means in this particular case the K is 4. D is the number of features that are used in the model. It may be 1, 2, 3 or 4, and it is always D is always less than or equal to K. And sigma cap square is nothing but the estimated error variance. See, residual sum of square, the MAC is the average error or RSS divided by the n. So this is nothing but the average. In the same way, you can define the standard deviation of the error, and you can define the variance of the error. So the sigma cap square denotes the estimated error variance. Now the first metric that I am going to define here, CP, defines like this. It is the equation like this: 1 divided by n plus in the bracket RSS plus 2 times d sigma cap square. So now see here, this RSS term is modified by adding this term. The purpose of this addition of this term means that D denotes the number of features that you are going to use in your model. If the number of D increases, this your RSS goes on increasing. Means whenever you are adding more variable, this term tries to penalize it by adding this quantity into the RSS, and you are going to select now that model in which the CP is smaller one instead of the RSS that is smaller one. Another metric that is commonly used is again the modification of this term. Now instead of this term, now we are dividing by n multiplied by sigma cap square. So this term is called as the Akaike information criteria or AIC. The third criteria that you can use if you are data is Gaussian distribution, then this criteria is used. Bayesian information criteria. In the Bayesian information criteria, the term is further modified by having log of n. This quantity you need to be minimized in while selecting the model. The fourth criteria that you can use is the adjusted R square, and the adjusted R square is defined like this, where here the RSS is the residual sum of square and TSS is the total sum of square that we have defined on the first slide. So n minus here D is the number of features that you are using in your model. Now, this is all about selection criteria. Then there are different methods which can be used to select the one model out of 2 to the power of p possibilities. And the first method is called as the subset selection. We are going to see each and individual method. Then second method is called as the shrinkage method. And third method is called as the dimension reduction method. Now I will explain all these three different methods. There are three different kinds of algorithms are there for subset selection method. The first algorithm is called as the best subset selection algorithm. The second algorithm is called as the forward stepwise refinement algorithm, and third algorithm is called as the backward stepwise refinement algorithm. Now the algorithm for the best subset selection goes like this. There are three different stages are there. I will explain this. In the first selection, your model building process starts with the null model. It means that there is no, you are not going to consider any input variable. Now in the second state, the second step is a iterative process, and this process runs p number of times. Here what is the p? P is the number of input variables. See here, p is the number of input variables. Then in our case this p is the 4. Now this iterative loop runs has two substeps. In the first substep, in the first iteration, you are going to generate all models. Suppose that in the first iteration you are going to generate all the models containing only one input variable. In the second iteration, you are going to generate all those models in which you are going to use only two input variables. If you in the third iteration, all those models are generated which is using three input variables, and so on. So this model runs up to p number of iterations, and The second step of the iteration is that out of these different iterations, suppose now in the second iteration you have generated all the models involving two input variables. So now out of this you need to select only one, and you are going to use the criteria here, that is the RSS or the R square, and you are going to select the model having the smallest RSS, or you are going to select the model having the largest R square. Now, when you complete the execution of the this iterative loop, you will have p number of models, and now your task is to select out of those p number of models only one model, and now you are going to use the criteria that we have defined: CP, AIC, BIC, or the adjusted R square. So this is the way in which you are going to execute the algorithm. I am going to explain this algorithm with one our particular example. Now the best set selection algorithm starts with a null model, means no input variable is considered, or the zero, and here the predicted value y cap is always equal to y average. In the second iteration, when the loop execution starts, you are going to generate all those models containing only one input variable. So in this step, four different models are generated here. The first one use only CGPA. The second model uses only attendance. The third model uses the gender, and the fourth model uses the MSc. Now you have here four models. Out of these four models, you need to select only one model, and the criteria that you are going to use here is the either R square or RSS, residual sum of square. You are going to select the model having smallest RSS or the largest R square. Now for example, suppose that the model MSc, the model that uses mid-semester examination marks to predict the end semester marks, that had highest R square and the smallest RSS, then the MSc is selected. So this is the selected model. Now in the second iteration, you are going to generate all those models which contains two number of input variables. Now in this case, you have generated six models. Oh, see, CGPA plus attendance, CGPA plus gender, CGPA plus MSc, attendance plus gender, attendance plus MSc, and gender plus MSc. So these six different models are selected. Now out of these six, again you need to select only one, and the criteria that you are going to use is R square or the RSS. Suppose that you have selected this model in the second iteration. In the third iteration, you are going to generate all those models now which contains three input variables. The select generated models are CGPA attendance plus gender, CGPA attendance plus MSc, attendance gender plus MSc, CGPA gender plus MSc. Now again you are out of these four models, you are going to select only one, and the criteria that you are going to use is R square or the RSS. Now suppose that you have selected this model, CGPA attendance plus MSc. Now in the fourth iteration, you are going to select you are going to generate the model which contains all the input variables. So this is the only one model that you are generating in the fourth stage, and this is the selected model is the same as that of the generated model. So in all here you have generated how many models? This is the first model, and this is the second model, this is the third model, and this is the fourth model. So this is the first model, this is the second model, this is the third model, and this is the fourth model. Now you need to select out of these four only one model, and the criteria that you are going to use for this selection in the final is which criteria? Either you are going to use CP, AIC, BIC, or the adjusted R square. Now suppose that in this out of this four model, suppose that attendance plus MSc is the attendance plus MSC is the model which has the smallest residual adjusted R square. So in that case, you are going that model is selected. Suppose this is the case. So this model is selected if it has the adjusted R square smallest. So this is the way in which the base subset selection algorithm works. But the drawback of this base subset selection algorithm is that in this case the for loop is executed to 16 times, which is nothing but the 2 to the power of 4, 2 to the power of p. So this base subset selection algorithm is computationally expensive one. Now we can have thus we need to have an efficient model selection algorithm. So this model selection algorithm is further refined. So in the second type of algorithm is called as the forward stepwise refinement algorithm. In the forward stepwise refinement algorithm, what it is done is that you are going to add uh, in model one variable at a time. Now you will start with the null model like in the previous case. In the first iteration, you are going to generate all those model out of which contains only one single variable. So now these four different models are generated. Now suppose that by using the criteria of RSS or R square, you have selected MSC. Now, once the MSC is selected, in the second, this MSC is kept as a constant, and now you are going to add to the MSC other input variables. Now, by keeping MSC constant, you will add CGPA, you will add attendance, and you will add the gender. Now, these three different models are generated. So out of these three different models, by using either RSS or R square, suppose that you have selected attendance plus MSC. Now in the third step, this attendance and MSC is kept constant and the third variable is added. See here attendance and MSC is constant and the newly added variable is the PCGPA. Here the attendance and MSC is constant and the gender is added. Now here sorry, this is not so so these two different attributes models are generated. Now once these two different models are generated, out of these two, suppose that you have selected this one. In the final step you are going to select you are going to add gender into the fourth step. So out of this four step, now you are going to use the criteria, what it is called as the AIC or BIC or adjusted R square. So that criteria you are going to perform, use to select the out of these four different models. So see here, the number of that models that are generated here are less. These are the four. 4 plus 3 7, and in this case 2, so only 9 models are generated. So this number of models that has been generated are reduced from 16 to the 9 in case of the forward stepwise refinement. In the forward stepwise refinement, algorithm works like this: one attribute is added in the every iteration. So this algorithm is called as the forward stepwise refinement algorithm. There is third kind of algorithm is there which is as efficient as that of the forward stepwise refinement. It is called as the backward stepwise refinement, and it works like this. You are going to start with all the four attributes here, or in general all the p attributes. Now in the first iteration, what you are going to do is that you will generate the models by eliminating one attribute each. So here the eliminated attribute is the PCGPA. Here the eliminated attribute is the attendance. Here the eliminated attribute is the gender. in the fourth case, eliminated attribute is the MSC. Now these four different models are generated here. So out of these four models, suppose that you have selected this, and now this is kept constant. This is taken as the input, and out of these three, you are going to delete one attribute, and you will generate the two attribute models. So these are the three different models that you have generated. Now in the next iteration, you will suppose that this is the model that you have selected by using the criteria like RSS or the R square. This model is selected. Now while selecting, you are generate two models which contains only one attribute by eliminating either one. So this is the case. So now suppose this is the model is selected. Now once these three models are you got, you will select out of three models. You will use the criteria to select one model out of these three. The criteria that you are going to use is the AIC, BIC, or adjusted R square. So by applying this criteria, you are going to select one model out of these. So this is about the model selection and the different approaches for algorithms to select one model out of 2 to the power of p number of models, where the p is the number of input variables. Thank you.